Yeah, we're working linear inequalities, and we're going through and working some examples. And I have somehow lost my, oh, there it is. Okay. Couldn't find my stylist. Alright, so there's going to be a little bit of a new twist here to this one. Alright, so we're going to have negative 1 is less than or equal to 2x plus 1, and that is going to be less than 10. So it's the same thing that we've been doing, except we're going to break this up into two pieces. Okay, we're going to break it up into two pieces. So we're going to do this piece first. All right, and we've been doing that. That's nothing different. And then we'll look at 2x plus 1 is less than 10. Okay, so the first thing we want to do is let's go ahead and take this 1 here. Let's just, well, I mean, we're subtracting 1 from both sides, right? I mean, that's what we're doing. But I'm trying to skip that part at this point. And kind of shorten our time. Alright, but we will multiply both sides by a half to get the coefficient of 1. A coefficient of 1 there. The coefficient of x is 1. Multiplying both sides by the reciprocal. The reciprocal of the coefficient. And now we're left with, so we have a half times negative 2, which is negative 1. And 2x times a half is just x. So, there we go. X is greater than or equal to negative 1. Alright, let's look at the other side. Let's draw a divider line down through here. Okay. Alright, so we have 2x plus 1 is less than 10. So once again, we're going to move this 1 over to the right hand side, and its sign changes, so we're left with 2x is less than 10 minus 1. We're just subtracting 1 from both sides. So now we have 2x is less than 9. 2x is less than 9. I guess we better continue this divider there. And what do? We multiply both sides by a half. That is the reciprocal of the coefficient of x. All right, multiplying both sides by a half. This is all getting kind of crowded, isn't it? It's getting really crowded. And we're left with x is less than 9 halves. X is less than 9 halves. All right. Let's draw this on a number line so we can get a picture. We have x is greater than negative 1. So let's just arbitrarily pick a point right here, and we'll call that negative 1. And x is less than 9 halves. We'll just arbitrarily pick a point here that x is less than 9 halves. Let's go back to x is greater than or equal to negative 1, right? Now this includes it, so we put a solid dot there. And let's look over here. This is x is less than 9 halves, so we're going to put an open circle. So it's everything between. It's everything between. X must be greater than or equal to negative 1, and x is less than 9 halves. So it's everything in between. So you can pick a number in here, like for example 0, and if we plug to 0, let's go back to our original inequality. If we plug 0 in here for x, you would see that this should make this a true statement. 2 times 0 is 0, and we're left with just 1. Well, is 1 greater than or equal to negative 1? Yes. And 1 is less than 10. See? Pretty simple stuff. Okay. Now let's go ahead, since we've been doing this, let's write this in interval notation up to 9 halves. But it doesn't include 9 halves, so we put a open parentheses there. Okay? Or closed parentheses, I guess you'd say. Closed parentheses. Alright, moving on. I'll see you in the next vid.